is the circumference of a circle. Because that one's weird. I can't do the curvy line. Area gets more interesting now, right? So the most basic area is the one I think somebody was already trying to yell at me earlier. The area of a rectangle is just length times width, right? And that only makes sense because what you're really getting, if this is, let's say length is 5 feet and the width is 4 feet, that means that this is, let me see if I made this, so that's 5 feet, right? That means this is 4 feet, so I get these little, I actually get these little squares, right? I mean, and you guys know this, but it's really easy to forget what area really is. It's just saying how many little square feet, foot by foot, fit. And of course, the shortcut for that is this is like the definition of multiplication from way back in grade 4 or 3 or wherever the hell you learned multiplication. 4 rows with 5 in each row is, of course, 20. And what's the unit's going to be? Yeah, feet times feet is feet squared, so square feet. So it is 20. If you count, of course, there's going to be 20 little ice cubes in this thing, right? You guys with me? I mean, sometimes you just kind of forget that, and an area gets all confused. It's nothing more than that, right? Volume is actually the same thing. I just now have an actual cube. I have all 3 dimensions, but we're going to get there. So that's the most basic area. Square is really just a rectangle. So I don't really need a formula for this. The only difference is if this is the length of a side, then that's the same. It's the same stupid formula though, right? S times S just happens to be S squared, but do I really need that as a separate formula? No. Okay, cool. So here's our first freaky shape. And it's not that freaky yet. But what is a parallelogram? What's the... You may remember, it's got a certain word in there that should give it away.
Multiple sides.
How many sides?
4.
4. 4 sides.
4 equal sides.
Where two of the 2 pairs that are opposite have to be both parallel. And therefore it actually comes out to be equal length, yeah. So a rectangle is a special parallelogram. It's a parallelogram that somebody straightened out, right? Parallelogram is just a tired rectangle. So a parallelogram could look like this here. As long as this side is parallel to that side and this side is parallel to that side. Right? Now here's the problem though. If this is, let's say, 6 feet long and this is 7 foot long, is the area 6 times 7? No, that's kind of, it goes against the idea. Why was this one so easy? Because they're at right angles to each other already, right?
Because you have to divide that up like into two separate triangles and then box it up.
You could do that, but you could have this one triangle here and then move it so it's over here. Right? So therefore I made a rectangle out of it. The idea though is you see this all the time, especially with like triangles. You need something perpendicular to the other side. So that's why for a triangle you need the true height, which is perpendicular to the base. Is this perpendicular to the base?
No.
No. What does perpendicular mean? Makes a make a right angle, right? Cool. So if I pick this triangle up, this one here, and put it here, don't I make a shape that we know? The problem is I need to know what that length is there, right?
Can you also have like a dotted line up there to make like a rectangle?
Yeah. Oh, over here?
Yeah.
Oh, sure. You could take this triangle and put it there, but I just chose to take that one and put it there. It's the same rectangle you would get, right?
Yeah.
Now, to tell you honestly, all I need is to be given the height. So this is actually called the slant height, which kind of makes sense, right? That's the slant height. That's not the true height. So if somebody, if there's a pile of books and they're kind of like stacked and kind of leaning over, I wouldn't measure this way to say how tall they are. I would measure straight up from the ground, wouldn't I? Perpendicular to the ground. That's the idea. That's the slant height, not the true height. So somebody have to tell me what this is. And let's say it's, I don't know, 4 feet.
Isn't there a way to find that without you telling me?
Well, I have to kind of know the angle too. The nice thing, I can cover my ass because I didn't tell you how wide this is. Right? But it has to follow. Now we're a little ahead of ourselves, but for a triangle, the sides for a right triangle, it's got to follow what Greek dude?
The three,
Pythagorean theorem. Right, so that's coming up later. We really don't need that yet. All I need is somebody to tell me the height, and I'm golden. Right? So the area of a parallelogram is the base times the actual height, which is really the same formula as this. It's just that what's the actual height? There's the base, it's the length. The actual height is the width. Right? This is easy because it's already a right angle.
Isn't it 1/2 based on height?
No, you're thinking ahead. If I cut this in half, I make a triangle, and that's why triangles are 1/2 based on height. Right? So a parallelogram is base times height. In this case, it would be 7 times 4, 28 square feet. How you guys doing? Now this might sound familiar. If you didn't really study too much parallelograms, or your teachers use different symbols, then the BH makes you think about 1/2 BH. But that's triangles. And where's that formula come from?
The whole degree, because it's
Every triangle, if I draw a triangle, it's part of, if I just copy it, turn it over, it's part of a parallelogram. It's exactly half of that parallelogram, isn't it? So if I know the height of the triangle and the base of the triangle, the parallelogram would have been height times base, right? Base times height? Let me write it like that. So how much is only my triangle then? It's going to have to be half that. That's where that formula comes from. Cool.
What's the name for this shape?
So this is and that's just me putting the parallelogram, right? This is just a triangle. Just a triangle, yeah. You gotta love that. Triangle, 3 angles. Right? Okay. So far, nothing ground shaking. Right? This is all stuff that we kind of know. The parallelogram might be a little bit, you might have forgotten it or never seen it too much like that. The one shape that definitely requires a little bit of work is a trapezoid. Does anybody remember what the hell a trapezoid is? Careful, no, not 8 sides.
6 has 4. It's 4 with 2.
Yeah. Who knows what an 8-sided figure would be called?
No, it's an octagon.
Octagon. Right, what if I-
Sorry, octopus, they have 8 legs.
Octopus has 8 legs. I love it. So octagon is 8 sides. I love it. Okay. Trapezoid is not quite as rigid as a parallelogram in definition. Parallelogram, both sets of sides have to be parallel. Trapezoid, only one set of sides parallel. So the most classical way to draw a parallelogram is a trapezoid is something like this. Right? How we doing? Okay. Now to give you some, we're going to derive the formula for this. And just before you guys get too freaked out, we're suddenly loaded with formulas here, aren't we? I will let you write these formulas down on a sheet of paper, or your formula sheet. You can't put little names or shapes next to them. You have to know which is which, but I'm not going to make you memorize any of them. For the volume formulas, I'll let you say, because that gets a little bit freaky. But for the area formulas, you should be able to tell which is which. How's that? Yeah, fair enough, exactly. That's my thought exactly. Now, the trapezoid, just to kind of look ahead a little bit, doesn't a trapezoid look like somebody's beheaded a triangle?
Yeah.
Just to be really morbid for a minute. It's a triangle that's lost its head. So the formula for a trapezoid should somehow have that feel to it. It should have like a triangle feel to it. And let's be a little more specific about it. Another reason that's true is because, and this is what somebody else was talking about earlier, if I cut this here, I've made 2 triangles, haven't I? So let's call this triangle 1, and this is triangle 2. How are we doing?
Yes.
So this will be base 1, because this is the base of that triangle, right? And this will be base 2. How are we doing? This might sound familiar to some of you guys. And then, of course, the other important thing I need for a triangle is the height. And the height is the same for both of them, isn't it? How do I know the height's got to be the same?
Because
2 lines are parallel. They have to be the same distance apart. I love it. That's awesome. Parallel lines mean they're the same distance apart no matter where I look. So, of course, both triangles have the same height, don't they? This height here must be the same as that height there. All right, let me shut up for a second. How's everybody doing? And again, the derivation is important, but you'll just be using the formula. I don't want to get there. And the height's the same for both. So what's the area of triangle 1? What's the area of 1?
Base
Base 1.
times half.
Times height.
So 1/2, its base times the height. What's the area of triangle 2?
The same
Half.
base
1/2, its base
times height.
2.
times height. So what's the area of the trapezoid?
So
The
together.
two,
Yeah,
the two
1/2 B1H plus 1/2 B2H. No, in my head I'm thinking, anyway.
Isn't it like half and half? So
Yeah, what can come out?
You can.
No, careful, what can you take out?
B1.
I can take a 1/2 out and
Yeah.
an H,
H.
right?
Yes.
And I'm left with B1 plus B2. That's a little algebra.
Yes.
Alright, okay, that's what it is.
Oh yeah, everybody cool with that? Area of the trapezoid?
Yeah.
Yeah.
You don't have to put a little T there if you don't want to, but I just want to make sure you understood. There's a lot of different areas up here, aren't there? Area of the one triangle there, the other triangle there. If I put them together, I get the area of the whole thing, don't I? And that's really important. That's going to come up to the circle thing that I'm going to do in a minute. If you ever hit a shape, you don't know what the area formula is, you try to break it into shapes that you know the areas, and then just add them back together, right? Stay with me now.
I think what's there's the two different ones like that one, the A.
That's for a square. It's not really different though. Even the squares get the same formula, just as that they happen to be the same size. That's a rectangle, that's a square.
Okay. But we don't do anything different.
No, in fact, the square is just a specific type of rectangle, so it really has the same formula.
Yeah.
Just happens to have the same number there. Yep. Now, so far, this should be basically a review, which comes out in some of the comments recently. This shouldn't be that hard. Here's a part that's kind of interesting, though, and it's cool to hear that you've seen this before. But the area of a circle is definitely interesting, because by itself, I can't base it on anything. It's not a square, for sure, right? It's no sides to it, no points. It's just this, right? We know what's going to show up in it, though. Some maybe, but definitely pi is going to show up somewhere, right? Whenever we deal with circles, it's going to pop its head up somewhere. Here's the cool thing, though. We're going to do the same thing we did here, believe it or not.
Yeah.
We're going to cut this. So first off, all the way around is what? So let me set up a couple things. Here's the radius, right? So what's all the way around would be circumference, which is no,
No, sorry.
based on what I've given you.
Oh,
Sure, that's another name for it. What is it? Circumference equals
2 pi.
2 pi r. Oh, okay, right? Cool. I know. It's always like, what the hell does he want from us? But that's all I wanted. Right? That's for everything I know. That's what the circumference is, right? 2 pi r. So what's the distance from here to there? Pi r. I love it. Let me stop right there. Does everybody see that? All the way around is 2 pi r. Halfway then would be pi r. How are we doing?
Wait, repeat that, please?
All the way around is 2 pi r.
Correct.
So what's halfway around? 1 pi r. Cool. Now here's the cool part. And you see why now. Someday I'll actually bring construction paper. But I still haven't, so it's too bad for me. If I took this and cut it straight down the diameter like that, and then cut triangle pieces, like I'm cutting some pie, right? And now I'm going to get hungry. All right, and of course, I can make some stupid math jokes about pie, cut pie, whatever. So just pretend I did, and everybody go, yeah, whatever. All right, thank you. And don't cut it all the way out. So if any of you guys, I don't know if any of you guys are into origami and paper folding and cutting and all that kind of crap. I'm not really, obviously, but don't cut it all the way to the edge. So is everybody, so cut it all the way, so almost to the edge, so it's still connected, right? Can you guys imagine if I pick this up and open it, what will it look like?
Folded a piece of paper.
Right? If I pick this up,